Welcome back. So this figure actually is from a textbook, but I kind of changed the problem. Basically here my goal is the following one. Imagine that you have hurricane season coming over and you want to buy a generator or multiple generators in order to be able to provide enough power to your house in case that you lose electricity. So in this case, we know that the efficiency of a power cycle simulated by the generator is about 28%. So imagine you know that the total amount of power that you need is WA plus WB. So what is better? Or if it's possible, is it better to have two generators, each one with basically the same power, WA, WB, or is it better just to buy a bigger generator with the combined amount of power? Okay, so let's see first which one of the two options is better and to see if actually both of them are possible or not. So like always, I like to do my own figures. So let me go and do my own figure over here. Alright, so basically what we have over here, let's say we're gonna have a hot reservoir which is gonna be connected in this case to a first power cycle A. So this one would be creating WA, and now this one will be giving power, heat to, let's say, to a medium tank over here, and this tank will be connected to another power cycle B that now will be connected to a cold reservoir, and this one will provide WB. Okay, now we have this one, this big over here, let's say will be A plus B, we provide the power or the work WA plus WB, and will be connected to a same reservoir with this temperature. Okay? Alright, so let's say over here that the efficiency for this cycle here is theta A, this one is theta B, and this one would be theta AB. Okay? Alright, so by definition, what is efficiency? It's whatever we're trying to get out divided by whatever we put in. So the efficiency here of A will be equal to what? What are we trying to get out? Power. What do we put in? Heat. Okay. Wait 1 second because I'm gonna have to change the notation QL, and maybe let's call this one here Q instead of L, like this one, let's say M. Okay? Alright, so let's go back to this one. The efficiency for this one is whatever we're trying to get out divided by whatever we put in. So this one will be equal to what? Q hot minus Q medium divided by Q hot. So this will give you 1 minus Q medium over Q hot. Alright? Now for the second one, we do the same thing. What you're trying to get, the work B, what you put in, Q sub M. This will be equal to what? Q sub M minus Q low divided by Q medium. So we get 1 minus Q low over Q medium. And now we do the same thing for efficiency of this one. Okay, so this will be equal to what? What we're trying to get out is work A plus work B divided by whatever we need to put in Q sub H. So here, if you want, probably you have the intuition that this actually should be equal to what? Q sub H minus Q sub L. But if you want, just to check, let's use this expression. So WA will be equal to what? Q hot minus Qm plus Qm minus Q low divided by Q hot. So you can see right away that this will give you that the efficiency AP will be equal to what? This Q medium will cancel, and we are left, as we were expecting, with Q hot minus Q low over Q hot. So this will give you 1 minus Q low over Q hot. Alright, so here the idea is just to see if we can actually rewrite the efficiency of this one in function of the efficiency A and B. Okay, and let's see if it is possible to come up with an engine that will operate like these two engines. So to see if we're able to come up with a generator, one big generator that is able to operate like these two over here. So what we're going to do, to give you an idea, is that here you see we have the efficiency of the combined is Q low over Q high. Here we have Q high, Q low, and the common denominator is Qm. So the first thing we're going to do is solve this equation here for QH. Then we're going to solve this one for Q low, and we're going to substitute into this equation over here. All right, and let's see what happens. So basically we solve this one for QH, this one for Q low, we substitute over here and see what happens. Okay, so our first equation we had was efficiency of A equals to 1 minus, this should be Q medium over QH. So we can solve this equation saying what? That 1 minus the efficiency of A will be equal to Q medium over QH, which will give you that QH will be equal to what? Q medium divided of 1 minus the efficiency of A. Alright, so we did the first one over here. Now we can take the second one, which is efficiency of B equal to 1 minus Q low over Qm. And this will give us what? 1 minus the efficiency of B will be equal to Q low over Qm. So now this will give us that Q low will be equal to Qm times 1 minus the efficiency of B. Alright, we're almost done. Now we look at the efficiency of the big generator, would be AP. We found that one to be equal to what? 1 minus Q sub low over Q sub hot. So this will be equal to what? 1 minus Q sub low is given by this expression, Q sub M of 1 minus mu sub b, and q sub h will be given by q sub m divided by 1 minus mu sub a. So you can see right away that the q sub m will cancel out. And basically what we have at the end is that the efficiency of the combined AB will be equal to 1 minus efficiency of A times 1 minus the efficiency of B. So if we do the algebra, this will give you 1 minus what? So we do 1 minus efficiency of B minus efficiency of A plus efficiency of A efficiency of B. So you can see that this one will cancel out, and at the end we are left over with the efficiency of this generator here compared to the efficiency of each one of these two generators must be equal to what? Efficiency of A plus efficiency of B minus the product of the efficiency of both of them. All right? Okay, so now this is the important part. So we say that the efficiency generally of a generator, so that's for this case, let's just say it's about 28%, so 0.28. So if we want to have the equivalent to this system over here, to the two generators in series, what should be the efficiency of this big generator? So that will give us that the efficiency of the big generator should be equal to what? 0.28 plus 0.28 minus 0.28 square. And if you do the calculation, this is equal to 0.482, which will imply that the efficiency of the big generator, the A plus B, must be of the order of 48.2%, which basically is not an option, because you know the maximum efficiency you can get from a generator is about 28%. So in this case, what is the conclusion? Is that it is better to buy two generators, because with only one, that generator will not be efficient enough to provide all the power that you need. Okay, thank you for your attention.